Okay, so ngayon i-try natin i-check kung we need to consider the P delta effect. So bali, ang gagamitin natin sa pag-check ng P delta effect to. So as per SCI 3E10-14R, tapos okay, ESCA 7-10 yung gagamitin natin. Ito yung definition niya. Okay, so una, kailangan natin kunin yung ratio of shear demand to shear capacity for the story between level X and X-1. Or simply, kung makikita natin doon sa ESCE 7-10, sabi rito, okay, from this formula, that is the stability coefficient, yung Px times the delta the displacement times the IE over the Vx is times the HSX times the CD, where Px is the total vertical design load at and above level X. We're computing Px, no individual load factor need exceed 1.0. The delta, the design story drift as defined in section 12.8.6, occurring simultaneously with the shear X in inches or the mm, while the IE, the importance factor, determined in accordance with section 11.5.1, while the Vx, the seismic shear force acting between level X and X-1, it's either in kip or in kilonewton. The HSX, the story height below level X, or this is in inches or in millimeter. The CD, the deflection amplification factor in table 12.2-1. So ito yung kailangan natin, yung amplification factor. So bali, gumawa na ako dito ng Excel formula. So kailangan natin kunin yung beta. Yung beta na yan is the ratio ng shear demand at shear capacity. Sabi rito, saan na yan? Where beta is the ratio of shear demand and shear capacity for the story between levels X and X-1. The ratio is permitted to be conservatively taken as 1.0. Kaya yung 1.0 natin, ay yung beta natin is 1.0. Then for the importance factor, so na pick up na natin yan, that is 1.0. Then yung CD natin, bakit 5.5? So as per to ESC 7, yung CD natin, this is CD. So papasok dito sa special reinforced concrete moment, kaya 5.5. Okay, so pero kung ordinary or intermediate, depende na sa inyo, pero yung gagamitin natin yung special, kaya 5.5. So ito naman, kailangan natin kunin yung level. Yung level pala guys, kailangan natin i-set up muna yung model. Dapat naka-ascending yung pagkasunod-sunod. Then of course the story height, then the P per story, then the shear, yung diaphragm para makompute natin yung displacement, tapos yung elastic stability coefficient. Okay, tapos ito yung maximum stability coefficient, yung allowable. Tapos may check natin kung we need to consider the P delta effect or not. Okay, before that, kailan natin to i-save yung model. Save as. That is the service condition. Service condition. Service condition. Condition. Then save. Okay. So balik tayo dito sa Excel file. Kailan natin to yung para sa service condition. So bali change natin, i-modify natin yung mga members natin according to this chart from SCI. So para sa service condition, para sa beam 0.5, para sa column that is 1.0. Okay. Then para sa wall natin is 0.5. Then para sa slab, that is 0.35. Okay. So balik tayo sa ETABS. Select natin yung lahat ng beams. Then assign natin sa frame property modifier. Ang sabi rito, para sa mid is 0.5 the I. Ito, IJ, the torsion, tapos yung moment of inertia. The torsion is 0.5, 0.5, and 0.5. Okay, so 0.5, 0.5, 0.5. Yung torsion, tapos yung moment of inertia. Then, apply. Then select natin yung columns. Then assign natin yung 100% para sa torsion moment. Kasi sabi rito yung torsion tapos yung moment of inertia is 1,1. Then okay na yan. Hindi lang natin yung galawin. Then select natin yung floors or floors. Select natin yung properties na lang para sa slab. Ito. Then assign natin yung stiffness modifier. So stiffness modifier natin, sabi rito, para sa flat plates if model as shield. So yung moment natin is 0.35 lahat. 0.35 bending moment. Ito. 0.35, 0.35, then 0.35. Then apply. Okay. Then next is yung shear wall natin. Okay, so anyway, by the way, hindi pa natin na-select yung hindi pa natin na-analyze yung shear wall kasi naka-auto-select siya. So i-analyze muna natin para makapag-select siya ng dimension. Analyze muna natin yan. Just wait. Okay. So right click natin to. Okay. So punta muna tayo dito sa design ng shear wall. Yung preferences natin, it should be 40 yung reverse shear natin. Then okay. Wait lang, select natin to. Yung property ng wall. Okay. Or pwede rin mag-specify na tayo muna ng ano, ng sizing. Sige. Assign natin to as to as 250. Okay, then select natin yung wall. I mean yung shear wall. 250. Then assign natin shell the stiffness modifier. So sabi rito para sa wall natin, para sa crack, so moment is 0.5. 0.5. So, para sa binding natin 0.5, 0.5, 0.5. Okay, then apply. So okay na, na-select na natin, apply na natin yung mga service condition. So we can now analyze the structure. Just click this icon or analyze, then run analysis. Then wait lang natin na matapos yung analysis. Then ang speed ng analysis ng ETABS based din sa specification ng computer ninyo. Kung hindi kagandahan yung specs ng computer natin, so medyo matagal, katulad nito. Then tapos na tayo. Ang kailangan natin dito ikunin is ito, yung level height. So pero dapat i-change natin pala yung height. So ang kailangan kasi natin yung second floor up to the roof deck. Okay. I-unlock ko muna yan. Then punta ko sa edit stories. Ito, kailangan ko to i-change. Ito kasi hindi natin yung kailangan. Ito lang kasi yung may displacement eh. Ito pwede ka to 2 3, 4, 5, 6, 7 and 8. Then okay na yan. Click okay, okay. Then ulit analyze ko para kasi ano yung pag kasunod-sunod ng story natin is okay. Kasi kapag hindi natin sunod-sunod by numbering or by letters, maghalo-halo para hindi tayo mahirapan sa pag-copy paste ng result. So ito 2, then story height yung kailangan natin, yung P kailangan din natin. That's it. That is the story force, yung P. So kailangan natin pala yung DL plus LL. So balik na naman tayo. So stop ko muna yan, i-unlock ko muna yan. So kailangan ko mag-create pala ng combination. Ito combination pala, sabihin ko P. Yung P na yan, that is the SDL, tapos yung LL. I-include natin yung roof live load. Yun, this is the P, yung requirement. Ito yung P. Okay. Then okay. Then analyze natin yan. Analyze. hintay na lang muna ulit. Medyo mabagal na yung yung computer ko. Tagal. Yon. So punta tayo rito sa model, yung layout mo na story data. Ito i-copy ko na lang muna to. Yon. Ito lang yung kailangan natin. Okay, then yung para sa ito, delete mo na yan. Para sa P, so kailangan ko yung load P. Punta tayo rito sa result analysis, structure P, and then analysis result. The structure result, then the story forces. Yung P ay yung kailangan natin. P. This is the load P. Ayan. Then, kailangan natin yung bottom na result. Okay, then copy natin to. So, yung para sa share, so instead na P, yung EQX1 yung gagamitin natin, or pwede rin EQX2, EQX, dapat i-check natin yan. So for this presentation, check natin, gamitin natin yon EQX1. Then dapat i-check din natin yung EQXY. Okay, so mamaya i-check natin yan. QX1, ito kailangan natin to. Copy. Okay, then para sa displacement, okay, punta tayo rito. Displacement. Okay. Yung displacement natin is diaphragm center of mass displacement. So ito yung gagamitin natin. Ito. Diaphragm. So of course sa load combo natin, balik tayo. This is the EQX. So sa earthquake load yan. Ito. Then EQX, this is the displacement X. Copy natin. Then okay. So therefore, ito yung maximum natin. Ito, as from this value, ang maximum natin is 0.05. Ito yun sa ONA. Then the allowable is only 0.0909. That is 0.5 lang, the ratio of 0.5 over the product of this beta times the CD. Okay, so no P delta effect ang i-apply natin. So hindi natin i-consider yung P delta effect. So pero check muna natin yung kasi naka EQX pa lang yung share natin eh. Ito kunin ko naman na yan para naman sa Y. change ko to. Oops, kulang. This is, then copy natin para naman sa story share along Y naman. This is structure data story forces, then load combo natin yung P. Tapos of course yung bottom lang. Then okay na yan yung P na yan. Load combo, sorry. Ito EQY pala, sorry. EQY. So ito yung gagamitan natin. EQY. Oops. EQY ito. Hindi pala na-copy. Copy natin to. So far, no pedal type ang i-apply natin. So okay na yan. Therefore yung structure natin, hindi na natin yan i-apply. Okay na siya. So ito, i-save ko na lang yung service condition na yan. Then balik na ako doon sa original model natin. Then open ito yung 4. Okay, so pwede natin to i-analyze. Analyze muna natin yan. Then check natin yung load patterns kung may effect yan during sa analysis. Kasi for example yung SDL, once na mag-animate tayo tapos hindi nag-move, ibig sabihin may problema dun sa modeling or the loadings. So wait lang natin, medyo matagal. Pero kung mga Alienware na laptop, mani-mani yan, or mga Predator, okay. So kung mapapansin niyo, that is DL. So mayroong movement siya. Then ito, just click it para ma-next yung pattern natin, load pattern. Next is the SDL. So may deformation, okay siya. LL, okay. LLR, okay. Dwarf deck. So EQX, okay. EQX 3 steps, okay. Sa Y naman, yung tatlong steps na yan. Then yung para sa wind load. So makikita ninyo ay hindi lang WLX then WXY, kundi 12 step yung chinek niya. Yan. So pwede natin ma-check rito sa elevation yung animation, yung movement ng building natin. So yun, stop natin na pili natin i-3D. Okay, so far yung lahat ng load patterns natin is may effect dun sa structure natin. So that's a good sign. Dalag tayo ah. Okay, hintay lang muna. So yun, ito yung ano natin, yung naka-extruded na structure. Mabagal yung ano natin ah. Okay, so ito yung ano natin, 3D model, extruded 3D model. So na-check na natin yung load pattern, so lahat sila okay. So sa ngayon, although yung model na to hindi siya wala siyang irregularities in terms of vertical and horizontal structure, pero i-check natin din para okay. So una, punta tayo rito, balik tayo sa home. By the way, before tayo mag-check ng vertical and horizontal irregularities, pwede muna tayo formulate ng or mag-define ng load combination. So balik tayo sa dito. I-unlock ko muna yan. Then define a load combination. Yung sa load combination, as per section 203 ng NSCP 2015, ito yan. Ito yung computation. Yung original, yung LRF, yung load combination using strength design or load and resistance factor design is 1, 2, 3, 4, 5, 6, 7. 2, 4, 6. So 7 load combination lang. Pero kapag i-compute mo yan, himay-himayin mo yan, abot yan sa 23 load combination. Plus mag-add ka pa ng service load to. So kaya yung combination ko abot sa 25 na load combination. So let's continue. By the way, ang i-compute lang natin dito is yung may changes. Ito, yung A na yan, yung earthquake load. Yung earthquake load kasi hindi basta-basta na substitute lang natin. Mayroon yang vertical and horizontal effect. Okay, let's continue. So from this code, sabi raw ang A is equal sa root times AH plus EV. Ito yon. So from the section 208.6.1. Tapos ang EV daw is 0.5 times CE times I times D. Ito yung para sa vertical component natin ng earthquake. So yung F1 natin, that is 0.5. Talaga 0.5. Ito yan for other live loads. Kaya sabi 1.0 for the floors in places of public assembly for live loads in excess of 4.8 kPa. So yung live load naman natin is 1.9 lang eh. And for garage live load or 0.5 for other live load. So papasok tayo rito 0.5, tapos yung say natin. Okay, so say natin yung kanina 0.44, yung importance factor natin 1.0, then yung rho natin is 1.0. F is storage ripple with check. Then yung AV natin or the vertical component of the earthquake is magiging 0.22. Kasi as you can see the formula from this given formula, 0.5 times CE times I times D is equals to 0.22 times D. So that is the dead load. Yung D na yan is a combination of DL itself, the self weight, plus the superimposed dead load. Okay, therefore, from this given equation, E is equals to rho AH plus AV. Substitute natin yung value ng AV, which is 0.22 times D. So, yung A natin is equals sa 0.5 EH plus 0.22 DH. Yun, then, yung EH na yan, that is equal sa positive and negative EQX, then positive and negative EQY. So, considering the positive vertical earth motion, yung okay, wait lang. Okay, so mukhang na-hide lang to. Na-hide. Yan. So therefore, from this given equation, we can formulate from it is equivalent to 1.42D plus, kasi nagiging 1.42D from this given equation, 0.22D plus 1.2. Ito yun. That's why magiging 1.42 tayo times D plus 0.5L plus 1.0 EH. Yung EH na yan is equivalent sa positive and negative EQX, then positive and negative EQY. Kaya kapag i-formulate mo yan, apat yung magiging ma-formulate natin load combination. Then considering sa negative vertical earth motion, kapag i-minus natin yung 0.22 sa 1.2, so magiging 0.98 na lang. Then considering this equation, apat na naman yung ma-formulate natin. Okay? Then for the positive earth motion naman, based in this load combination, 0.22 plus 0.9, ito yon, 1.12. Then considering this equation, apat yung ma-formulate natin. Then 0.22 minus 0.9 minus 0.22, ito yung magiging formulate natin. Yung 0.68D times plus 1.0 EH. Then considering this equation, apat na naman yung formulate natin. Kaya in total, abot yan sa 23 combinations plus itong combination na yan. So therefore, ito yung susundin nating combination. Okay? Okay. So let's continue. Punta na tayo sa ETABS. Then add your combo. So that is a 1.0 DL plus SDL. Add ako sa DL. Then okay. Then copy ko na lang yan. Mag-additional ako ng plus LL, 1.0 LL. Add ako dito ng 1.0 LL para service load. Then okay. Then actually may ginawa na ako dyan. Pinakita ko lang yung process. May ginawa na akong load combo. Then ang gagawin ko, tatanggalin ko na lang yan, then import ko yung load combo na ginawa ko. So bali may apps na nakita ko sa internet, credit sa owner nun. Hindi ko lang mahanap kung sino ang owner nun, pero ito yung ETABS. Yun, i-connect ko lang to sa ETABS. Then yes, import ko yung ginawa kong load combination. Then ito. Then as you can see, ito yung load combo na ginawa natin. Ito yun. Okay, then i-delete ko muna yung existing na load combination dun sa ETABS. Okay, then i-append ko to. Then okay, then close ko na yan. Then we can check the load combination kung tama na. As you can see, mayroon na rito. Check natin kung tumatama. 0.98 DL is DL, then 0.5 sa LL, then negative 1 sa EQX. So far okay na. Then okay lang tayo. Then we can analyze again it kapag naka-formulate na tayo ng load combination para ma-check na natin yung mga irregularities in horizontal and vertical. So wait lang natin matapos yung analyzation. Okay, so natapos na yung analyzation natin. Punta na tayo doon sa muna balik tayo. Ito sa vertical structure irregularities. So stiffness irregularities or the substory. So punta tayo sa section 208.4.8.3. So item 2 as per NSCP 2015 or by FEMA 451. So bali nakapag-create na ako rito ng Excel file. Sabi rito kasi ito yung sa FEMA. Although same lang. Ang ginagamit rito is per stiffness, base size stiffness. Dito naman sa sabi rito sabi ng NSCP, a soft story is one in which the lateral stiffness is less than 70% of that in the story above or less than 80% of the average stiffness of the 3 stories above. So bali dalawa yung check natin. Yung ito based sa irregularities using stiffness then as per the story drift. So una kailangan natin kunin yung stiffness lang. Then from NGL up to the RDL. So punta tayo rito. So analyze na natin yan. Yung reports, table. Then we can dito sa result, structure results, then yung nung kailangan natin stiffness, stiffness pala yung kailangan natin. Ito na, then story stiffness. Okay, so bali yung kukunin nating combination ito, pwede natin i-check yung EQX1 then yung Y. This is stiffness. Ito yung stiffness natin. Okay, from this up to the NGL. Then right click, copy. Click natin to. Then, so far okay, so walang substory as per the stiffness. Check natin yung along Y. Long way naman. Okay. So wala tayong Y sa drift. Ito, sorry. Ito yung natin sa drift. Right click, copy. Then natin rito, paste. So far walang substory. So pasado siya. Then next is punta tayo sa drift naman, story drift. Kunin natin yung story drift dito sa displacement, story drift. Then EQX din naman. Then kunin natin mamaya sa Y naman, Y axis. Copy. Then sa drift, paste. So far, wala tayong substory. Along X axis, kunin natin yung yung sa Y. Ito sa Y. Then copy natin yung drift. So far okay. So wala tayong soft story. So pasado siya sa irregularities number 1. Back tayo. So para sa weight mass irregular naman, check natin to. Sabi rito, weight mass irregularity. Mass irregularity shall be considered to exist where the effective mass of any stories is more than 150% of the effective mass of the adjacent story. A roof that is lighter than the floor below need not be considered. So bali check natin yan, yung upper and below, above, below and above story. So kailangan lang natin yung story mass. Para ma-check natin yung story mass, makuha natin yung data, kailangan natin yung center of mass of rigidity. So structure result, dito yan, ito yung rigidity. So this is kilogram okay. So pwede natin yan i-check along X and Y. So this time X muna yung gamitin natin yan. Okay, so after sa stiffness irregularities, so substory, pwede natin check irregularity sa weight, vertical geometry irregularities, in plane discontinuity and vertical lateral force. Ito yung sample niyan. Kapag yung shear wall is not continuous, whereas ang model naman natin is continuous. Tapos yung discontinuity capacity weak story. A weak story is one in which the story strength is less than 80% of that story above. The story strength is the total strength of all seismic resisting elements sharing the story of the direction under consideration. Yun, so may apat tayo na i-check under sa vertical irregularities. While in the horizontal irregularities, mayroon tayo torsional irregularities, then reentrant corner, tapos yung diaphragm discontinuity, tapos yung out of plane offset irregularities, then non-parallel systems irregularity. So assuming nagpas tayo rito, so wala tayong irregularities, we can now use the static. Ito, we can now use the static analysis. Kasi sabi rito, all structures regular or irregular in occupancy category 4 and 5 in seismic zone 2. So hindi naman tayo sa seismic zone 2. Number 2, dito tayo papasok. Regular structure under 75 meter in height with lateral force resistance provided by the systems listed in table 2.8.11 except where section 2.8.4.8.3 item 4 applies. Irregular structures not more than 5 stories or 20 meter in height. So irregular structure kapag hindi siya lalampas sa 20 meter height. Then sabi rito, structures having a flexible upper portion supported on a rigid lower portion where both portions of the structures structure considered separately can be classified as being regular. The average story stiffness of the lower portion is at least 10 times the average story stiffness of the upper. So, dapat mas matibay yung bababa, yung lower stories ng 10 times daw. And the period of the entire structure is not greater than 1.1 times the period of the upper portion considered as a separate structure fixed at the base. Tapos, sa dynamic naman, sabi rito, structure having a stiffness, weight, and geometric vertical irregularities of type 1, 2, or 3 as defined in the table 208-9, or structures having irregular features not described in table 28-9 or 28-10 except as permitted by the section 28.4.10.3.1. So kapag mayroong irregularities, automatically yung dynamic na yung gagamitin natin. Pero for this presentation, assuming na nakapasa tayo, so as you can see, nag-check naman tayo dun sa vertical. So papasok tayo sa static analysis. Okay, let's continue. Punta tayo rito. So far okay na yan. Okay, so i-check natin yung drift tapos yung base shear ng structure natin. First, of course, i-analyze muna natin yan. Then wait natin kung hanggang sa matapos to. So habang nag-analyze, check muna natin dito yung sa drift. Okay, so kailan muna natin input. Bali, may ginawa na ako ritong Excel file. 0.4a yung seismic source type natin. 7.2 importance factor 1, NA1, NV1. Then yung SD natin, yung soil type is of course 0.44 yung yung CE, yung CB is 0.64. Tapos yung R natin is 0.5 kasi konkreto. Then yung T natin, ito yung computed na period which is 0.768. Saglit, hindi pa pala to. Check muna natin dito. So this is a base sa height. So check muna natin yung height pala. Elevation, or pwede rin dito edit. Then so that is 23 sakto. 23 meters. So 23 meters. So ito na yung structure period natin, 0.768. Okay, for the base shear, so kailangan natin yung total weight ng building muna. So from the ETABS, so kailangan check natin yung okay, from the summary report, let's check the total weight. Ito pwede natin zoom muna. So ito yung height natin is 68.9. Check natin yung 23 meters. Yung 23 meters na yan times 0.3048. Baliktad. This divide. Okay. So that is 75.4. So this is from the foundation. So i-minus natin yan sa 2 meters kasi foundation yung 2 meters kasi foundation natin. So that is 21 lang. 68.89. So more or less pasok siya. Tama. Okay. Okay, so ito pala yung height natin 21 lang to. Kaya yung period natin is 0.717. So as you can see in this report of ETABS, so 0.717 tama as per the manual calculation. Ito, oops, okay, so ito yung computation natin para sa maximum 0.129 para sa base year natin, minimum naman is 0.0484. For the zone 4, minimum natin is 0.037. So kung ma-check natin, kailan pa natin yung weight lang, din ito yung weight natin, that is 15867 15867 0.8468 0.8468. Enter. So as you can see, ito yung base year natin 166. Then yung 2.5 natin is 2053. Then base year sana yan, wait lang, ito CBW RT. So ito yun, 0.129412. Ito yung ratio. Ito yung maximum equivalent of the shear wall. Base shear. Check natin rito. Okay, considering ito yung weight pala natin, considering 1 unit load, 1 kilonewton unit load. So ito yung may base shear natin, 0.105, 0.129, then 0.0489. Let's check in the ETABS. Yung maximum natin is 0.129. So tama to. Then tama yung sa ETABS. Then 0.04 para sa minimum naman 0.048. So ito tama. Then para sa zone 4 minimum natin is 0.037. 0.037 ito. Yan, 6. Okay siya. Then for the structure period, ito naman. Sobra kasi siya sa 0.7, so yung FT natin is 0.07 TV yung gagamitin natin. Okay. So para sa story drift calculation natin, limitation, so kailangan natin makuha yung change of M, or this is the drift. Punta tayo sa this is the maximum inelastic response displacement as per section 208.6.4.2. Then kapag makuha natin yan, so substitute natin sa equation 208-21 dito para makuha natin yung story displacement natin. Then kapag i-ratio natin yung story height, so papasok tayo rito. Ito yung drift ratio na nakuha natin, 0.0033. 6. So okay. From this more than kasi sa 0.7 more than sa 0.7 seconds, so magiging allowable natin is 0.0033 sa drift natin. So ito, sakto lang siya. Okay. So far, pasado tayo sa drift. So pwede natin i-check dito sa sa display response, story response effect, then maximum story drift, then yung EQX max natin. As you can see, the drift is 0.00127 yung max natin, which is the limit is 0.0033 kasi more than sa 0.7 seconds. Kung check natin yung Y naman, 0.0013. Check natin yung may earthquake na combination. Ito so far, ito yung mas malaki. 0.001 din. So okay na rin. Okay, pasado siya. Walang earthquake eh. So ito. So okay na yan. Close ko na yan. Then pwede na tayo mag-design. Okay. Okay, so let's come now in designing. Mag-design na tayo. So click natin to, concrete design frame, or pwede rin dito sa design, concrete frame design. Then click yung view revise references, then yung ECI okay na yan, type D okay na yan, then click OK. Then yung rebar selection columns for roles for columns. So for this interface, or for this time, we need to specify the rebar and columns. So kung gusto niyo na yung sa ETABS na pumili, okay lang din. So pero based on our initial condition, kailangan hindi siya bababa sa 16. Okay, ties okay na yan, 10 mm. Then para sa beam naman, same with column, yung i-minimize natin, or i-ano natin yung yung smallest bar size sa 16 is set up. Yan. Then okay na yan. Tapos select design group, then i-all ko na lang, all. Ito pala guys, punta tayo sa load pattern muna sa UBC. Ito yung overstrain factor 8.5, kinonsider ko yung shear wall as special, para same lang sila na 8.5, para isa lang yung analysis natin. Then diretso tayo ng design. So check natin to yung R. Ito. Ito yung ginamit ko, special reinforced concrete shear wall 8.5, para isahan na lang yung analysis natin. Okay. Okay. So dito na design, all. Then select combination. So i-select natin yung combination lahat maliban sa ito. service load natin ito. Yan. Then, okay. Then after that, pwede na tayo mag-start design check. Then click lang ninyo para mag-start design check. So mas magandang specs ng computer, mas mabilis mag-analyze and design yung mga softwares. Tagal na. Lang, inom muna tayong tubig. Tagal na. So, okay. Tapos na tayo mag-design. Okay, then after that, we can check or verify analysis versus design section. So, okay siya. Design, analysis and design sections match for all concrete frames. Okay. Then after that, we can verify all members passed. So there are 12 concrete frames failed the design check. Do you want to select them? Yes. Just click yes. Okay, so just click yes, then Control Shift J. So kung mapapansin ninyo, ito yung mga secondary beams na nagki-carry sa stairs. So i-unlock ko to, apply ko yan, assign. Wait lang, balik ko muna para makita natin yung yung error. Kasi dapat lang natin yan i-modify yung yung torsion. Dapat walang torsion doon eh. Okay. Sorry, di pa pala tapos. mapapansin ninyo, right click natin is naka OS 45. Yung summary natin, right click pala para makita niyo yung summary. OS 45 shear stress due to shear force and torsion. So mayroon pa rin torsion. Together exceeds maximum allowed. So kailangan natin i-release or i-modify yung torsion doon. Ito i-apply natin yung torsion as 0. Assign frame, then yung property modifier, ito yung torsion. Dapat wala yung torsion. Okay, then apply natin. Okay, check natin. Wait lang, analyze natin muna yan. Tapos na pala. So design ulit natin to, or pwede ito muna, check natin yan kung babasa na. So right click natin. So far okay na, wala tayong bagsak. So ipakita ko na, then i-redesign ko ulit lahat na. Then wait na naman tayo hanggang sa matapos. Tagal pa. So this tutorial is for academic purposes only. Na then after we design the beams and columns, i-detail natin, then we proceed of designing the shear walls. Tapos after that, i-design natin yung footing, tapos yung slabs sa safe. Malapit na. Okay. So tapos na tayo mag-design. Check natin kung may field pa. So all concrete frames passed the design check. So aside from this, pinaka-importante, kailangan niya check yung display ninyo yung design info. Tapos design output and identify all failures. Just click then apply. So check natin kung may mga failures pa. Kasi minsan yung software nagsasabi na okay na, pero kapag i-display mo yung lahat ng failures, mayroon pa rin. So far okay na tayo, pasado na lahat. Then from this point, punta na tayo dito sa detailing. Sa detailing preferences, okay na yan, meters ko na lang. Then concrete common, sa slab, hindi naman natin muna i-design yan doon natin sa safety design. Sabi mo okay na yan, CB okay na yan. Detailings still hindi naman tayo gagamit dyan. Ito sa beam, ito i-assess natin yan. Sige, 40 na lang, pero 14 assess natin yan. Pero kung kayo i-set ninyo 16, okay lang din. Pero kasi members, so 16 natin to. That is non-seismic, then seismic. Dalawa yan is setup. Medyo madami lang gagawin. Pero okay lang yan. Then click din nyo para sa seismic. Okay. Mali. 16. Yung natin guys, yung ABC, base yan sa lap splicing natin sa rebar. May general note doon si ETABS sa pinaka front. Then okay na. Then punta tayo sa column. Sa column mayroon din seismic din non-seismic. Okay na yan. Then largest 28, okay na yan. Seismic 16, okay na yan. Then click OK. Tapos after that, pwede na tayo mag start detailing. Then start detailing. So aside from using the software, dapat i-check din ninyo manually. Commonly using Excel, yun ang pinakamabisang paraan. Para sa column natin, i-check natin yung yung cage view. Ito yung cage view ng column natin. Okay. Okay, check din natin yung para sa beam, yung cage view ng beam. Let's say for CB1. So ito yung cage view ng beam. Okay, so after that, check natin yung schedule, beam schedule natin. Check natin to. So may dalawang 260 na continuous. Kung check natin yung yung general plan, general notes. Yung A, yung B, yan. So ito yung A natin, that is the continuous at top bars, while yung F sa bottom bars na continuous, tapos yung G is the extra bars at the bottom, then yung B natin is the extra bar at the top. Yon. So kaya makikita ninyo yung schedule natin may mga liter. Okay. Then yung stirrups natin at zone A, zone C is tatlo daw at 10 at 150 mm. Ito yun, yung zone A is from the both face, tapos tatlo 50 muna, 50 spacing, tapos before ka mag 150, tapos papasok na dito si zone C sa gitna. Okay, so sa column, ito para sa ano pa lang ito, beam. And para sa column layout natin, okay, kulang pa no, yung column schedule ito column schedule. Ibig sabihin from the base, so may 12 na 16 mm, then splice siya sa second floor, then splice for every 2 story nag-splice siya. Okay, and up to roof deck. So tapos na tayo mag-design ng beam at column. So this time mag-design na tayo ng shear wall. So i-close ko muna to, then select ko yung shear wall natin. Oops, properties, then ito 220. Select na natin kasi kanina 220. Auto select. Okay, auto select, sorry. Then punta tayo sa design preferences, 60, that is 40. Tapos rebar rolls pair, okay na yan, i-default na lang natin yan. Selection rolls for the wall spandrel, so naka-pair sa kasi tayo eh. Ito general pair section. Kung naka-pair ka, pwede ito i-modify or i-define. Tapos ito, assign pair. Kapag mag-assign ka ng pair, ito yung i-apply natin. Okay, so ito pwede natin to i-apply, assign natin. So unlock muna natin, assign natin yung shell as pair, label natin as P1. Isa lang naman yan eh. Then select natin yung previous. Oops, select yung iba. Select wall section, then auto select. Punta tayo dito sa add pair section. Yung pair section na yan, that is okay, may section na pala tayo. Ito na lang, ito assign pair section, uniform reinforcement is 3,000. Yung bars natin okay, so punta tayo sa shear wall design, sa preferences 40, okay na yan. Okay, then dito kailan muna natin select muna natin yung properties, then punta tayo sa view, revise spandrel overviews. Okay, yung length okay na yan. Ito yung materials natin 3,000, then okay. Tapos ito okay na to. Then start na natin eh. Oh, wait lang. Nandak pala to.